Projective Geometry, Volume 1, by Oswald, Veblen, and John Wesley Young.
Chapter 9, Geometric Constructions, Invariants. Section 88, Proposition Kn. If we form the product of n linear binary forms, a sub x times a sub x prime times a sub x double prime times ... a sub x n minus 1 primes, we obtain an expression of the form a sub x to the nth power equals a sub 0 times x sub 1 to the nth power plus n times a sub 1 x sub 1 to the n minus 1 power x sub 2 plus n times the quantity n minus 1 divided by 2 times a sub 2 x sub 1 to the n minus 2 power x sub 2 squared plus ... plus n times a sub n minus 1 x sub 1 x sub 2 to the n minus 1 power plus a sub n times x sub 2 to the nth power. An expression of this form is called a binary homogeneous form, or quantic of the nth degree. If it is obtained as the product of n linear forms, it will represent a set of n points on a line, or a set of n elements of some one-dimensional form. If it is of the second degree, we have, by proposition K2, that there exists an extended space in which it represents a pair of points. At the end of this chapter, there will be proved the following generalization of K2. Proposition Kn. If a sub x to the kth power, a sub x to the l power, ... are a finite number of binary homogeneous forms whose coefficients are proper in a space S which satisfies assumptions A, E, P, there exists a space S prime of which S is a subspace in the number system of which each of these forms is a product of linear factors. As in section 85, S prime is called an extended space, and elements in S prime but not in S are called improper elements. Proposition Kn thus implies that an equation of the form a sub x to the nth power equals 0 can always be thought of as representing n distinct or partially coinciding improper points in an extended space, in case it does not represent any proper points. Proposition Kn could be introduced as an, not independent, assumption in addition to A, E, P, and H0. Its consistency with the other assumptions would be shown by the example of the ordinary complex space in which it is equivalent to the fundamental theorem of algebra.
Projective Geometry, Volume 1. This book was written by Oswald, Veblen, and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renhold, with programming and illustration by Jim Renhold, 2019. Thank you for listening.